Today I felt like doing a proof, so let's prove both parts of fundamental theorem of calculus. There are two parts of fundamental theorem of calculus, but first, fundamental theorem of calculus states that derivatives and integrals are opposite, let's say, operations. And the first part is that if we get the derivative of an integral, we get the original function. So first, let's recall the definition of derivative. This is a limit as delta x, or maybe h as you want to write it, of f of x plus delta x minus f of x over delta x is the definition of derivative. And let's apply this to that, and our function is f of x. Well, I mean, I'll call it g of x is equal to integral of f of x from a to x dx. Let's apply this definition over here to this. So this is the limit as delta x approaches 0 of the integral from a to x plus delta x of f of x dx minus, the integral from a to x of f of x dx over delta x. Now we can do some algebraic manipulations and tailor this so some terms cancel out. This integral over here can be represented as the integral from a to x of f of x dx plus the integral from x to x plus delta x of f of x dx. Now you may have noticed that this integral, since it has a minus sign, will cancel out with this integral over here, and we will be left with only this integral over here, and this is a limit as delta x approaches 0 of the integral from x to x plus delta x of f of x dx divided by delta x. And here we applied something called mean value theorem. The mean value theorem states that for a continuous function, let f of x be continuous, on the closed interval a to b, and the differentiable from the open on the open interval from a to b. Therefore, there must be a point, let's call it C, such that f prime of C is equal f of b minus f of a over b minus a. C is a point in between a and b. So if you were to visualize it, it would look something like this. Say here you have a, here you have b, here you have c, and like this. Now it states that the slope of at C like this, is equal to the slope, like that is between the line B and A. This is kinda sketchy, so it's not 100% accurate, but I think you get the idea. Now, how does this apply to this over here? You will have something like f of x plus delta x minus f of x, and let's assume that capital F is the antiderivative of f of x, and this is over delta x. Now remember that the mean value theorem relates its antiderivative with its derivative, like in this example. And also remember that this is a limit as delta x approaches 0. So therefore this will be equal to the derivative of this, and the derivative of this was f of x, but evaluated at a middle point in between x and delta x. But now let's draw this line. Now let's say you have here x, you have a middle point c, and here you have x plus delta x. Now since delta x approaches 0, it means that as this quantity diminishes, this will become closer to x, and since c is always in the middle of x and x plus delta x, therefore c will approach x, and therefore this is equal to f of x, and we have proved what we were looking for.